Hello friends, today we are going to study the topic number 5th is electrochemistry. Now electrochemistry is the branch of physical chemistry that deals with the interrelationship between chemical energy and electricity. Now electrochemistry is also helpful to design and operation of electrochemical cells. In electrochemical cells, the chemical energy is converted into electrical energy or electrical energy converted into chemical energy. So this is generally studied in electrochemical cell, and this electrochemical cell is the part of electrochemistry topic. Okay. Now in this topic, first point we have given electric conduction. We know that electricity is what, or electric current is nothing but a rate of flow of charge in unit time. Now what is meant by conductor? The substance which can allows the flow of electric current is called as conductor. Means what? The substance which can conduct the electricity, that is called as the conductor. Now the conductors are classified into two types. Why the conductors are classified into two types? Because the mechanism of flow, that is electrons, is not the same for all the conductors. Okay. Therefore conductors are classified into two types, which gives rise the two types of conduction, and that is first one metallic conduction and second one is that electrolytic conduction. Now metallic conduction is also called as what? Electronic conduction, and electrolytic conduction is also called as ionic conduction. Now we will see the electrolytic conduction. Electrolytic conduction. This is also called as ionic conduction. So the conductors in which conduction of electricity occurs by migration of ions are known as electrolytic conductors, or also called as ionic conductor. Now electrolytic conduction, in this case, for example, the aqueous solutions of that salts, a solution of that acids and bases. In these solutions, free ions are available for carrying the electric current, for carrying that electricity. Okay, so the different solutions of acids and bases, they can conduct electricity very easily. Now we will see the next point, electrical conductance of solution. According to the Ohm's law, the electrical resistance R of a conductor is equal to the electrical potential difference V divided by that the electric current I, and therefore R is equal to V upon I. Now we know that SI unit of potential difference is what? Volt, and unit of that current, that is R for that in ampere. Okay, so therefore also is the unit of that resistance, that is ohm, and therefore ohm, this is also called as omega, is equal to what? Volt into ampere inverse. So this is the point what we have getting. Now we will see the next point, that electrical conductance. Electrical conductance, how we are to study. Now electrical conductance is denoted by G, that is, now we will see that is conductivity. For finding or for defining conductivity, first of all we will see that the electrical conductance. Now electric conductance is equal to the 1 upon R, means what? It is just reciprocal of that resistance, and therefore Z is directly proportional to what? It is the inverse of resistance, means what here? The cross sectional area directly proportional and divided by its area, means inversely proportional to the length. Therefore G is equal to, take down that proportionality constant K into A upon L. Now where the K is called, this proportionality constant K is called as that conductivity. Okay. Now if A is equal to 1 meter square and L is equal to 1 meter, then this equation becomes what? Z is equal to K. Therefore conductivity is nothing but equal to, that is electrical conductance. So conductivity is the electrical conductance of the conductor of unit length and unit area of cross section. In other words, conductivity is the electrical conductance of unit of material. Okay. Now we will see next electrical resistance of conductor. Electrical resistance of the conductor R is directly proportional to the length of that conductor and inversely proportional to the cross-sectional area of this conductor. Therefore, R is equal to what? R is equal to, take proportionality constant rho into L upon A, where proportionality constant rho is called, this is that particular rho is called as that here, that resistivity of that conductor. Proportionality constant is called resistivity. Okay, this. Now if L is equal to 1 meter and A is equal to 1 meter square, therefore above equation becomes R is equal to just rho. Okay. What is meaning of this? The resistance, electrical resistance of conductor is the resistance of unit length and unit cross sectional area. Okay, this is the way of that lines. Now we will see this electric conductance. K is electric conductance, G is equal to K into A upon L. You know that. Therefore, K is equal to what? Conductivity is equal to G into L upon A. Means transfer this equation for that K. And therefore, this K is equal to 1 upon R into length upon area. So, putting value of that G, this is 1 upon R. Okay. But rho is equal to that resistivity is equal to what? Resistance into area divided by length. Therefore, the conductivity is equal to, it is just inverse of that, the resistivity. Okay. So, the conductivity is the inverse of resistivity. This is the equation. Okay. We see unit of conductivity. We know that conductivity is equal to our electrical conductance into L upon A. Now, conductivity K is equal to, I have written here on that board, Siemens into meter upon meter square. Means what? The unit of electrical conductance is Siemens, and for length meter, for area meter square, and therefore from this to get this Understand? So SI unit of conductivity is Siemens meter inverse, or the omega inverse into meter inverse. In common unit, the conductivity K, that is unit for this in common unit, ohm inverse into centimeter inverse. Now we will see molar conductivity of an electrolyte, which is denoted by what? That is the symbol lambda. Now term is like this: molar conductivity means what? The concentration of solution expressed in different methods, like that the molality, mole fraction, molarity, formality, we have different methods. Why this term only used here? Because concentration of solutions mostly expressed in molarity. This is the molar. And what is meant by molarity? Molarity is nothing but is equal to number of moles of solute divided by volume of solution in liter. How many moles of that solute present in 1 liter of that solution. Now only conductivity K, electrolytic conductivity K, is not suitable term for study the different solutions. So this is comparing conductivities of different solutions is not useful only that way, and therefore scientists introduce, scientists introduce new term, this is that lambda, and therefore lambda is equal to what, or molar conductivity is equal to what, the conductivity K divided by concentration of C. Okay, so molar conductivity is nothing but or is equal to conductivity K divided by the concentration, that is C, of that solution. So now we find out SI unit of this. Suppose that the lambda. Now first find out, or we know that the SI unit of that K. What is SI unit of K? A, that is Siemens meter inverse, and concentration R in mole per meter cube. Okay, so mole meter cube inverse. Therefore, SI unit of lambda is equal to what? That's Siemens meter square mole inverse. But common unit of molar conductivity are common unit of lambda, or that molar conductivity, is omega inverse centimeter square. This is Siemens expressed in omega, meter square is that in centimeter square, and this is mole inverse. This is just common unit, and this is SI unit of that, the way of molar conductivity. Okay.